Okay, this is number 3 in section 2.1. And the problem says, or problems 1 through 16. So, a homogeneous second order linear differential equation is given, right? This one right here. Two functions, y1 and y2, and a pair of initial conditions are given. So, here are our y1 and y2, and here are our initial conditions. First, verify that y1 and y2 are solutions to the differential equation. I'm actually going to skip that part because you guys know how to do that already, right? You just input each of these guys in here, make sure, take the derivative, make sure it equals 0. Then find a particular solution of the form, and I'm going to go ahead and write the form. So goal, right? We've been finding, again, a lot of general solutions, but we want to find a particular solution. So y, I'll just call it y sub p. And, well, the form that they give you is C1 Y1 plus C2 Y2. They don't write the YP. I technically should just write Y, but once we find our C1 and C2, then it'll be a particular solution. That satisfies initial conditions, and of course, primes denote derivatives with respect to x. Okay, so two main steps. We need to find our general solution prior to our particular solution. So the nice thing here is we're given our y1 and y2, so we already know what the general solution looks like. We can say y of x equals c1, okay, well that's times cosine of 2x plus c2 times sine of 2x, right? So I'm given these guys, so they're right here, right? There's my y1 and there's my y2, so, check. Okay, now our goal is to find, right? So again, if you want to think about it in steps, right? Step 1 is find your general solution, and step 2 is now our goal is to find y sub p. Well, what haven't we used? Well, we haven't used our initial conditions, and so that's how we're going to find, right? That's going to help us find our C1 and C2. And another way of saying this is we impose the given initial conditions on this general solution in order to find our particular solution, or sometimes they say imposition of initial conditions. Okay, so let's go ahead and try to find our y sub p. So we have, so here's my y of x, so I'm going to need to find y prime of x. So this is all differentiation. So I'm going to find the derivative of this guy. Okay, so that's just a constant, so it's c1. The derivative of cosine of 2x, the derivative is negative sine 2x times 2 using the chain rule. So that's going to be, let's see, negative 2c1 sine 2x plus, okay, now we're going to take the derivative of this guy, right? This is just a constant. So the derivative of sine 2x is cosine 2x times 2, right? Using the chain rule. So this is going to be 2c2 sine 2x. Okay, now I don't need to find the second derivative, unless you want to for fun, but our initial conditions, right? It only involves the first derivative, so we don't need to find the second derivative. So now let's impose our initial conditions, right? So imposition of initial conditions, right? IC, not IOCD or ice cream. Okay, sorry, having too much fun here. Let's see. So we have y, okay, so y of 0, right? So I'm using my first initial condition. Y of 0 is equal to, well, there's y of x, so I'm just inserting 0. So I have c1 cosine of 2 times 0. Well, 2 times 0 is just 0. So I can just write cosine of 0 plus c2 sine of, again, 2 times 0, which is just 0. And that is going to give me an output of 3. So now we just have to find what the cosine of 0 is and the sine of 0. So here's a nice little trig review. And so the cosine of 0, so that means my angle is at 0, right? 0 degrees. And the coordinates are 1, comma 0. Well, the cosine of 0 is the x-coordinate, so that's definitely 1. The sine of 0 is going to be 0, so that's basically going to be gone. So this implies C1 times 1, which is C1, is equal to 3. Okay, so there's our C1. So now our C2 is going to be, well, let's use our y prime of x. So we have y prime of 0. So again, I'm using this guy. So that's negative 2 C1. And did I write a sine, cosine? Oh, this should be cosine. Sorry about that. Cosine, sine, sine. Okay, so now with the correct derivative, we have negative 2 C1 sine of 0 plus 2C2 cosine of 0, and I know that's equal to 8. And so what does this imply? Well, we love sine of 0 because that's just 0, which means that all that is 0. So the sky cosine of 0 is 1. So I get 2C2 equals 8. And of course, C2 must be 4. Okay, so we can write our YP, our particular solution. And just so we can see the big picture here, so my Y, right, there was my Y of X. My general solution, so y sub p of x is going to be with C1 and C2, so there's my C1, there's my C2, and I have 3 cosine 2x plus 4 sine 2x with my C1 and my C2. So there is the particular solution to this second order linear differential equation.